So this has to be studied in the first chapter itself, but we did not take it. So last class, I am just give you a small part of that. How can you get the tan theta and all that? Okay. I hope it is visible to you. So
Ma'am, can you zoom?
at present, what we require to find out the theta. Logarithm and logarithm, I know that. Even I teach you, you may not use it because you are good in manual multiplication and division. Suppose you have got a big number. Suppose you have got a big number to multiply, just like this. Just like I can just give you that, for example. mm, 25, 6, 8 into 3, 4, 2. So like that some numbers. Nowadays you are okay with this big number. So in this case, only we are using this logarithm sum and anti-logarithm. Okay. So what we do means, I'm just give you a small nutshell for you because main thing is how to find out the theta. That is what we require. So if you want to find out 2562 into 348, 2562 348, how do you find out the value of this and value of this using logarithm? Okay. So what the first step means, you have to first look for 25 in this. 25 in this. Okay. So you have 25 here. I got it. You got 25 here. Now, after that, you go to next digit. It was 6. So in 25, go under the 6. So under the 6, you are getting the value like 4082. Still did not complete. There is 2 is here. There is 2 is here. Okay. So how do you find out the 2? You cannot find out in this. You have to go for the mean differences here. So under 2, what is corresponding to 25? So corresponding to 25, it is 3. So you just add that number to that. It means 4083. So corresponding logarithm in 2562 is 4083. Now, not that over. One more thing is that you have to count how many digits are there. How many digits in 2562? How many digits? It's 4. So when you want to write a complete logarithm, what is the next step means? How many number of digits are there in that minus 1? So 2562, 4 digits. 4 minus 1 is 1. 4 minus 1 is 3. So final answer that you should write it. So this 4083 as decimals and this 3, number 3. How do you get number 3? By counting how many digits are in this. Total 4 digits. In that minus 1, this is a method. There is no theory behind it. This is how we do it. First, identify the corresponding decimal by using logarithms and mean differences. Then 1, 2, 3, 4. How many digits are there? Okay. Then 2562. 2562. There are 4 digits minus 1. Minus 1, that is 3. So these numbers as decimals and whatever you reduce, number 1, that is 3. So the equivalent value of 2562 is 3.4083. Okay. Now, next I have given you number 348. So this is equivalent to 2562. Okay. Now we go to 348. Similarly, go for 34. You go for 34 and after 34 it is 8 number I have given. So go under 8. So it is 5416 under 8. So 342 48 is equal to 5416. There is no other digit, only three digits. So we can stop there. We don't have to find out the mean difference. We can stop there because it has only three digits. First two digits, this column, identify under 8 or 6, whatever, and this is not required because it has got only 3. Similarly, 3 digits, found the number 1, 2, 3 minus 1. So it is going to be 2.5416. So we find out a equivalent number related to that. Now, what we do means instead of multiplication, we just add this. So that is how logarithm is helpful for you. Instead of multiplying, what these quantities we add together. So when you add together, you will get 3.4083 plus 2.5416. That is why in the practical whole we are using logarithm because we are getting very big number. So in using logarithm, multiplication going to be addition and division is going to be subtraction. So that is the transition from using logarithmic table. Whichever number you multiply, get the equivalent number using logarithm and add. In the case of division, whichever is the number, get equivalent in logarithm and then subtract. There is no need of dividing and there is no need of multiplying. So this is the method in logarithm. So when you do the practical, you may get a number 2.4689 like that it goes on. So in that cases, we can make use of it. Suppose you have 24683 like this. 5 numbers. 5 numbers cannot be done with this method. You only consider first 4 numbers in that. If it is 5 digits, because we can only find out the numbers with the 4 digits. We cannot have. So what we do means, small classes you have to round off, no? Round off to the next 10, next 100. So same method. You want to ignore these 3. Look whether it is a 5 or less than 5. If it is less than 5, you can ignore it. If it is more than 5, you add 1 number to here. So logarithm table we can only use with the 4 digits. Now we can add it. 6 plus 3 is 9. 1 plus 8 is 9. 4, 9. And total number what you are getting 5.9499. But still our answer did not complete. Yeah. Once you found out logarithm, next step, find the final answer. Final answer, not this. We had to look for anti-log. So what is the use of anti-log? Previous thing we have got answer 5.9499. So I'm going to write here 5.9499. So that is 5.9499. Okay. Now in this final answer is this number. We are going to get this number using anti-log. If you look at here, on the first column, all are 0.11, 0.11 like that. 0.11, 0.12 like that. Okay. So that means we have to keep 5 here. Don't touch the 5 at all. Take 0.9499. So this is 0.01, 0.22, 0.230. So for us 0.94. Look for 0.94 here. Same as it is. Look for 0.94 here. And under that, go under 9 here. Under 9, you got it 8892. 8892. Again, one more digit under mean difference, go for 9. Under mean differences, it is 18. So, same as it is, just add this mean difference to this. And you will get a number. Okay. So, add is 8, 10, 8 2s are 10, carry 1, 2, 9 2s are 11, 9, 8. So, this is the 8910 what we got it corresponding to 0.9499. Now, what we do with this? You see, our question is, if I go back to that, question is 2562. 2562 into 348. So it is going to be in thousand. You know this answer is going to be thousands or 10,000s or something. You remember that. Okay. Just to do everyone manually do just what answer you will get in this. Let us see whether are we getting the same answer correspond. There will be some changes of the decimal here, children. There will be some, if you use logarithm and the calculator, some changes will be there. Okay. So, what I did, what I told you, let us go to the back, get a corresponding value in the logarithm, and according to the digits, -1, you will get 3 points, something like that. Then, take the second digit, find the corresponding value, 348. In that also, you will get a decimal. Afterwards, add both. When you add, you will get a number here. Then corresponding to that decimal number, look for in antelope corresponding. So 0.948892, mean difference is 18 under 9. So 8 2s are 10, 1 1 11, 9 8 9 1 0. Now we are not yet completed. Now what we do with it? What we do with it means there are 5 digits, but we have only 4 digits. Okay. So, in final answer, you should get a number more than 5. This is only, this is only, this is only 4 digits. There is a number 5 point is there, 5 is there. So, what we do means, according to that much digits, we have to shift this number. Shift this number to left side. Okay, if you get it, this is 0.8910, no? We have to shift it. How many fives are there? Shift it to the left. So when you shift it, 8910, 5 digits. We have 1 digit less. Add 1 0. So this is how we can find out in antelope. Okay. And anyone can tell me what answer? How many zeros? Can you tell me 2562 into 348? Anyone can do manually and give me the answer? Let us check what is the difference between both of them. I know that you think, ma'am, this is very tough. It is easy for us to multiply manually. Okay, I save the time. Actually, this is used in ICSE, very common. In CBSE, we don't use much this. Children don't use this actually. Yes. You will get 1 minute. Don't I will get the answer because otherwise we can save the time since we have to teach 892562 into 348. Yes. In that you will get 89156. So 1 digit more less. So we have to add a 0. So total 5 plus 1 digits we have to add. Final answer. We have to add 5 plus 1 digits. For example, uh, uh, 0, 0, 0, yeah. But you see, children, see the difference between this number and this. Calculator is different, but here some decimal is different because there is no other way. So there is a limitation for logarithm. Okay. For example, anti-log. Anti-log. So for example, anti-log you are getting around 2.356. So if you get the answer, just imagine 2.356. Let us find out the anti-log of it. Anti-log of it. Just see, this is the answer. We got it after using logarithm. Let us find out the anti-log of this. Go for 0.35. Go for 0.35 under 6. So under 6 is, and sorry, under 6 is 2270. Under 6. There is no fourth digit. There is no fourth digit, so you don't have to worry about it. Just write 2270. Look at this is known as Mandisa. So this is actually in some another book. In our NCRT, we don't say all that. I am getting from ICSE, they are using this. Especially in the lab and all, they have to write the values of logarithm and anti-log. CBSE, they don't say, but we have to teach. So that's why I'm teaching you. So 2.346, this is 2. So in this answer, your digits should be shifted is 3. How many numbers in this? You have to shift it plus 1. So your answer is going to be 227.0 because that many things have to be shifted. So that is finding log and anti-log. So I know that you may not use much this. What we require, I just taught you how can you find out. If you get a big number multiplication, if you practice this is going to be very easy. You can save the time if you practice it. Okay. So once again I repeat, what's the first step? First step, get the number corresponding logarithm. And how do you get this decimal? When it's all number decimal, reduce number of digits 1. Then write it there. After adding or subtracting, go to anti-log. Go for decimal numbers from there. Get the value corresponding using this. And suppose you are getting 1.34. Your answer should be, suppose just imagine it is 6566. That is your answer. Here it is 1. You have to shift 2 numbers. Suppose there are 0.34. That is your answer you are getting after using anti-log. If suppose your answer is this, you have to shift only 1 decimal. It's like that. Means 1 number to the left. 1 number to the left. Okay. And if it is negative number, we use bar 1. For example, logarithm. In this case, you are getting a number is 0.24. 0.24 into 0.3. Just imagine this is a multiplication you have to do. So using logarithm, forget about point and all, just go for 24 here. Go for 24, you will get 3802. Now, number of digits, not decimal. Here there is no. We don't look for this one, we look for the number before decimal. It is 0. So there is nothing to reduce. But what you have to do? 0 minus 1, you will write bar 1. Bar 1.3802. That is the peculiar feature of it. Okay. Bar 1. In this, since this decimal number, we don't count these digits. We usually count the digits before decimal. In the first question, I was just giving a full number. So there is no issue of this. You just count it and minus. But in this case, you have a decimal number. There is no number before the decimal. It's 0. So 0 minus 1, bar 1.380. It is negative 1. Actually, negative 1.3802. Similarly, 0.3. 0.3, you don't have 0.3. Look for 30. Logarithm. Look for 30. 30 corresponding to 30, you are getting 4771. Again, you will get the answer bar 1.4771. Add it. You add both bar 1, you will get negative 2. As usual addition. Afterwards, go back to and log. Look for the whichever answer you are getting decimal. Suppose you are getting bar 2 in the answer. Yeah, just imagine you are getting answer something like that. Something like that, you are getting the final answer after finding and log. It is bar 2. Bar 2, so what we do? Negative 2 plus 1. So you will get negative 1.6656. So if you do it, you will get it that the same answer. Okay. So anyway, it cannot be taught in within one class. But what actually we require is mainly we are using this now thetas. Okay, sine theta, cos theta. If you get a 35-degree, how can you find out? Because you only know 60. You only know 60, 30, 40. Let us go to that first. But that is now we can use. Since CBSE is not telling you to use this logarithmic table in addition, multiplication and division, but in practical sometimes we have to use. That is what I just give you the insight of the how can you find out the multiplication of big numbers and division. And ICSE, it is compulsory during practical exam of +1. They have a marks +1 also. They have practical, not like our CBSE. There's an exam, and they have to indicate the logarithmic values whenever do addition. Okay, children. So this is I have already taught you in the last session natural science. If you want to find out the value of 15-degree, okay, if you want to find out the 15-degree, look for 15 and get the value. You will get sine 15. Sine 15-degree corresponding 0.2588. Okay. Now, just imagine you are getting 15.5 degree. Now, this is the one. It's a all number, but 15.5 degree. Then corresponding value, look for 15 and under zero point 0.5 degree, there is a value is given. Okay, 2678. So, our answer is going to be corresponding 2672. Okay, so that is sine theta. Now cos theta. Now this book is downloaded in this way from the net. So this was the same, nothing more. If it suppose cos 16 degree, go for 16 degree, get it. Suppose there is a 0.6 something, under 0.6, how much is the value? You can write it down. So, as I told you, this is a multiples of 6. Each degree, 0.1 degree is a multiples of 6. 6, 12, 12 minutes, 18 minutes, it goes on. Then shall we go to the inverse? Natural cosines. Natural tangents, I think I have already showed you in the previous class. Natural secant. Let us go to logarithmic sines. Actually, we had to cover in the first session, but anyway. And children, this is what we give you: tan inverse, cos inverse, sine inverse. So this is the sheet, logarithmic sines. This tell you sine inverse. Suppose you are getting answer is around, just say 0.84 or something like that. Something you are getting answer like that. Let us go. Any other option is there in that circular radian squares. I'll come back to there. At least I show you other features. I'll show you. Then I come back to that. So this is the sheet of squares. You can find out any number of squares. Same way, 656. If you want to find out 656, if you want to find out 656, instead of squaring, go to 65 here, under 6, which is the number, and sorry, under 6, which is the number, you will get 430338. So these are the big numbers can find out from the thing. So let me show you other features because I don't want to repeat again. Time is running short. Now square root. You told we have square root of 2, square root of 3. You remember all that we have done in the problem. Now this is how by using this is all very useful for us. More than the first one. First one, we can make use of this. If you have a logarithm book in the exam, sometimes in the board exam, they give the values. And sometimes they will just give you this sheet. They don't give you the values. They just give you a copy of this sheets in the exam. Then you have to find out. So that's why I am wanted to teach you this. Okay. Look. Square root from 1 to 10. If you look at for square root of 2, see the answer is here. So square root of 2 you are getting from this 1.414. So that is square root of 2. So we don't have to calculate. I know that we have learned how to find out square root in small classes, I think so. Then square root of 3. Square root of 3, you can find out 1.732. Then square root of 5. Square root of 5, you will get 2.238. So like that. So suppose if there are number like that 27 or something like that, 27 something like that, as we have seen, this we can find out only 1 to 10. We cannot find more than that. Okay, only 1 to 10. Let me see the bigger number. Yes. Next sheet we have square root from, yeah, this is from 10 to 100. Okay. 10 to 100, 25. 25, you will get 5. Square root of that you already know. 24, 4.83899. 14, 3.742. Okay. So, okay, children. So, these are the some features. Now, Saris come. So, we will wind up the session now. So these are the different thing you will get it. Next is reciprocand or not require. At least square root and require. Okay. Okay, sir. I'll wind up the session.